Hello again and welcome back to the channel. Today's video is going to cover the basics of dialing in your fuel for your Fox Body Mustang using a Moates QuarterHorse, binary editor, and EEC Analyzer. And if you've been watching a lot of my videos so far, we've really been focused on how to change some different things in binary editor, but I don't think we've really even made a video yet where we've gone into EEC Analyzer to look at some data logs and figure out how that can be used to help us make some adjustments in our tune. And the mass air transfer is probably the main thing I use EEC Analyzer for. Now I can calculate this stuff manually in Excel, and sometimes you can just eyeball it and do a pretty good job too, but there's a really good tool there that helps us. So in this video today, what we're going to cover are the main things you'll adjust in your tune to get your fuel dialed in, which really comes down to your mass air transfer and your injector high slope, low slope, and brake point, how a mass air transfer works and how your mass air meter works, the basics of adaptive learning, which is essentially your computer learning how to add or decrease fuel at various points in driving conditions so that it stays at the ideal air to fuel ratio, what things you'll need to data log in order to accurately take a look at that, what you'll need to adjust, how you can look at those logs in EEC Analyzer, and some tips on when you then load your next tune. There's a couple things you need to remember to do or else your next log is not going to make a whole lot of sense. So in binary editor here, this is an old tune I did a long time ago that was around, it was actually an 89 Celine with a totally bone stock engine top to bottom. And so this was one where I was preparing it for a supercharger, so I had changed out some of the fuel system and did a few other things, but ultimately I was still running the stock mass air meter and just trying to make sure that the new injectors were okay before I strap the blower on and go down that path. So the first thing I want to talk about is your mass air transfer. So in your air category and your air MAF, you have the MAF transfer, which you see here. The way this works is that, when air comes through your mass air meter, this sensor voltage increases. Based on this, it does a lookup to see how much air should that equal. And then, of course, based on a certain amount of air, the computer adds a certain amount of fuel that should be an appropriate match for that. So what that means is if you go into your tune and adjust any of these kilogram per hour values for a given cell, if you increase this, you're basically telling the computer at a given voltage, I have more airflow, which means at a given voltage, it's going to give you more fuel. And if you're running rich, you would lower these numbers, which would suggest that at a given voltage, you're actually bringing in less air, and so the computer puts less fuel to compensate. So these numbers are directly related to ultimately how much fuel you're going to get. Number goes up, you get more fuel. Number goes down, you get less fuel. So that's the basics of what you're doing here, but the question is, how are you going to know easily and quickly and accurately how to set these numbers based on a data log? When you're doing a data log, in order to use EEC Analyzer to measure that data log and to help you tune this mass air transfer, there's some things that you have to tune or it won't work at all. And then there's also some things that you'll want to tune. So in this data log here, I've got this screen set up where I've checked all the boxes for the things that I would typically log when I'm really trying to dial in my mass air transfer. Now, really almost any log I do, I'm going to do the air temp and the coolant temp just because it's a good practice. If you can't remember and you want to go look back at an old log, understanding kind of what operating temperature you're at can help. So always want to do that first. Now, these first two are musts. I mean, you have to tell the system what your voltage is and what your airflow is and feed that to EEC Analyzer if it's going to help you make a decision. So you have to have these two guys turned on. The next two that I would turn on, you have to have this load and load X because these decisions in the adaptive learning are based on these measurements here. So you need to have these two turned on. Your KAMRF's right here, and this is the single most important thing. This is essentially the computer's fuel trim based on what it's learning. A fuel trim is a computer's understanding of your current tune and it either adding or removing fuel. And you have a side 1 and side 2. And if you remember from our last video, this is basically bank 1 and bank 2. Bank 1 on a Fox Body is going to be your passenger side of the motor, those 4 cylinders. Bank 2 is going to be the driver's side of the engine and those 4 cylinders. So anytime you see these 1s and 2s, that's because there's certain measurements that happen left side, right side. So the KAMRF is the fuel trims. This is essentially, the LAMSI is the air to fuel ratio that the computer is asking for in order to be happy. You have your HEGO sensor. So this is the actual reading coming from each oxygen sensor that ultimately leads to fuel trims happening. This is your actual injector pulse width. So every time an injector opens, it stays open for a certain amount of time. The longer it stays open, with each pulse, the more fuel you're going to get through the injector. So this is a direct measurement of how long your pulse width is at a given time. If you've hooked up your wideband directly into your QuarterHorse and into your computer, which I'll cover in another video soon because I've got a guy locally that wants help doing that, you would be able to log that, and you'd always want to do that. You need to know what RPMs you're at because, again, your adaptive learning is based on a combination of load and RPM, so this is something you have to log. And then I usually do mile per hour, spark, and throttle position, although you don't have to do that for these things. And battery voltage. So your battery voltage has to do with your injector offset because as your voltage increases or decreases, fuel injectors don't behave the same way. So there's some parts in your tune where it's constantly adjusting based on what your current voltage is. So that's something you want to log. This also, for you guys that are changing altitudes frequently, this can have a pretty dramatic effect on some of this stuff. So you want to log your barometric air pressure sensor. You also have your measured injector pulse width offset. So these are the things that I would log, plus your injector delay, one last thing. So these are the things I would log when I'm trying to measure my fuel as a whole, but right now we're going to focus on mass air transfer. So let's say you turn all these things on and you run your data log. Now, there's really kind of three different conditions. When I think about fuel, there's three types of things that I'm trying to tune, and I'm really focused on one at a time. So if this is like a first fire-up combo and you have no idea what's going to happen, you're hoping for the best, obviously you're not going to go beat on the car right away unless you think it's going to be safe. So the first thing that you would want to do is focus on idling. If you can't get it to idle well, it's probably not going to drive well. If it doesn't drive well, it's probably not going to be working well at wide open throttle. So the first thing that you focus on is idle. So I would turn all these things on, I would start a data log, and I would just let it run. And what I'm watching mainly is these two guys right here. So when you're logging, while it's actually logging, you can stay on this screen and all these values are going to update in real time as things are happening. So you can look at it just kind of a raw data grid this way, or you can run it from a dash view where all of these things are going to light up as it's working. And on the factory dash that Binary Editor ships with, you'll have a KAMRF 1 and KAMRF 2, so you can see what those numbers are as they change. And you can also see down here, this is your left and right bank measurements coming right off the oxygen sensor. And it kind of it moves back and forth because it's constantly switching. So when it's down on one side, that means you're running lean. When it's on the other side, it means you're running rich. And if it kind of hovers generally in this middle area, things are probably pretty good. So let's say you turn the car on and maybe it's running rich. What you're going to notice is initially, before it starts to adjust itself, it's going to peg all the way up here at probably 1 volt and just stay that way because your car's running rich. But as it warms up and once the adaptive learning kicks in, which only happens once you get up to operating temperature, your KAMRF is going to start adjusting. And as it starts to adjust, it'll start to pull fuel out because it knows it's running rich. So what you'll see is the KAMRF number, when everything's perfect, it'll be 1.0. But if it's running rich, it's going to reduce fuel. So it's going to start going down from 1.0. So let's say, hypothetically, you're running 10% rich. Instead of being at 1.0, it'll be at 0.9. So basically, you can just think of that as a 0 to 100%. 1 on this KAMRF equals 100% of normal fuel. If it goes up, it's adding fuel, and if it goes down, it's reducing fuel. As it adjusts, and it'll kind of move slowly, it'll go from 1.0, and then it'll drop a little bit, and it'll drop a little bit, probably in like little, 0.01 increments. And then eventually it will stabilize and it'll stop moving, and that's when it's adjusted far enough to believe that it's okay. Now, it'll only adjust so far in the tune also, and you can adjust in your tune how far it's allowed to adapt, but by default, it's only going to adapt about 12% up or down from whatever the tune says it should do. If you do want to change that, down here in this adaptive learning category and right here. So these are your basically minimums and maximums. So it will adjust up to adding 12% fuel or pulling about 12% fuel. And again, you can adjust this if you want, but it's up to you. And so if you're really like running really, really, really rich, more than 12%, then, it's going to adjust as far as it can, but it'll stop. So what that means is when you're looking at your dash, it's still probably not going to be happy and centering right around that mid-range in the green. So, but that's okay. So you run your log, you do this, and basically just let it idle, and you're watching for when did my KAMRF stop moving, and hopefully it doesn't peg out. If it pegs out, then that's okay, stop. We'll go adjust the tune, run this again. It should be a lot closer, and then maybe on the next one, it'll only have a little bit further to go. So you run all these things, you log it, and then I'm going to look at this log in binary editor real quick before we jump over to EEC Analyzer. So here on this chart view, I had my tune, I ran a log, and right now I'm really just caring about the KAMRF 1 and 2 and what RPMs I'm at. And so what you notice here is that as the RPMs are going up and down and I'm driving and doing things, my KAMRFs don't really stay flat. They're constantly changing as well. Because again, it's making adjustments based on a combination of what RPM you're at and what load you're at. And it has these different cells of learning, these different spots. So as you're driving in that part of your tune, you know, then it has some stored memory, and that's called your KAMRF, your keep alive memory, is what KAM stands for. And then when we go over here, this is a part where I was idling. So you can see my RPMs drop down to about 700. I'm sitting at a stoplight. And so these KAMRFs are pretty stable in here. And if you look at the two numbers we have, right here, KAMRF 1 says it's about 0.96 and KAMRF 2 is about 0.975. So what that tells me is on both sides at idle, I'm running a little bit rich, about 2.5 to 3.5% rich. So we need to lean things out just a little bit. And so when I talked about earlier, like sometimes you can just eyeball this stuff and look at it. This is kind of what I'm talking about. And since idle, you're not constantly fluctuating RPMs and load. You know, idle's one that's actually kind of easy to adjust manually, but I still want to show you how to do it the right way and how to use this tool in EEC Analyzer to help you do that. The first thing you have to do, so now you've saved your data log, you're going to have a file saved to your computer somewhere. Now you jump over to EEC Analyzer. And when you open that up, you're going to start on this data log tab at the top left, and you'll have to go to open your data log. You'll select it from your list, wherever that is. And then once it opens, this whole grid populates. And this is just a raw data feed of everything you chose to log for, you know, the entire time you were open. The next thing you'll do is go to this MAF area right here. What you'll need to do is you need to plug in your current mass air transfer into this voltage and flow number 1. It's important that this goes on to number 1. So to do that, I'm going to go into my tune. I'm going to go look at my MAF transfer. And I'm just going to click into any of these cells, it doesn't matter which one, hit Control A on my keyboard, which will select all, right click, and I can copy that. Go back to EEC Analyzer, go up to the very top left cell, which is the top voltage, and paste that in. Okay, so this is my current mass air transfer I was using while I did that particular data log. The next thing I want to do is I want it to try to calculate for me what an ideal mass air transfer would be if, you know, it reads all those adaptive learnings and makes some adjustments. So to do that, I hit this calculate button down here, but before I do that, I have some control over these guys and these guys. So the first thing it's asking you is, based on that entire data log, do we want to make these adjustments based on when the car was in open loop, when it was only in closed loop, or a combination of both? And do you want to make a decision based on what your wideband was reading, which you can only do if you have your wideband hooked up, and some of you may not have that yet. And honestly, for dialing in idle, I would actually recommend you use your fuel trims. So I would usually go to fuel trims long or both. Both is probably a good starting point for you guys. And your adaptive learning is not going to kick in until you're in closed loop anyways. So for idle tuning and just normal driving conditions when you're not a wide open throttle, you're usually going to want to make these decisions only based on closed loop. So I'm going to put those two things in, and then I'm going to hit calculate. It runs very quickly, and then you see over here on the right, I have now essentially a new mass air transfer, and this is based on its recommendations. Don't just take all these values and assume that it's always right and plug it in, because it's not always right, but it's a general guide to help you kind of think about things. So as we work our way through here, look at some of these values. So right here, factory, or the way I had it before, was set at 90 kilograms per hour. It's telling me now in that area, I think we should only have 88. So what that means is the computer was running a little bit rich, And so it's suggesting I lower these numbers just a little bit and it'll lean that out. We go to the next cell, factory had 82, now it's suggesting 79, means it was running a little bit rich. It's asking me to pull some fuel down. Now right here, it's almost exact. I mean, this is probably within 1%. So these two right here, it's almost perfect. Here, running a little bit rich, running a little bit rich, just a hair rich, hair rich, hair rich. You kind of get the idea, and that's kind of what you have. Now, when you get to the bottom here, you're never really running the car at 0 volts. So whatever your lowest measurement is, regardless of what it tells you, you would generally want to copy that the rest of the way down. You know, that's kind of the lowest reading that it has. Okay, so you get that. Now, keep in mind also that when you're in closed loop and when you're reading fuel trims, when you start to get a certain way up into the top area of this transfer, your car's not probably running in closed loop anymore, because when you mash the throttle or even get most of the way down the throttle, it switches to open loop. And the other thing is that your air to fuel ratio is going to go significantly richer on purpose when you get into those higher load areas, because as the combustion chamber has more pressure and more heat, you need a little bit more fuel. So you're no longer running at 14.64 or thereabout. And that's only what your factory oxygen sensors are capable of understanding and reading. So when you're in heavy throttle conditions, those sensors can't help you tune anyways. That's the whole reason you need a wideband oxygen sensor that can read that full range of air to fuel ratios that you're potentially commanding, give you some better data. So what that means is in this particular log, I did mash the throttle a little bit, and now it's freaking out up here and thinking that I need to add like 20% more fuel, and that's completely false. It's thinking that because that oxygen sensor can't even read that rich, and it doesn't know what to do, and it's totally telling me to do some very stupid things. And this is why you never want to just paste in this whole table. But since you're only focused on idle, you're probably going to be down in these bottom cells right here. Going back to our visualization of our log originally, one more thing I'm going to pull up here. I'm going to add in the current voltage and the mass air reading so we can look at those as well. And you'll notice that if you look at the kilograms per hour idle, you know, we're really down in this 23 area, and the voltage is hovering, you know, about 0.47 to 0.5 volts. That's my idle area. So if you think about that, if I'm down at around 0.47 to 0.5 volts, and this says I'm running 2 to 3% lean, if we jump back over to EEC Analyzer and look down here, notice that it's having me reduce that area a little bit. It was at 13.6 before, and it's suggesting I go down a little bit. And it should be roughly 3%. So the way we would calculate that is I'm going to go look at what it was originally, 13.624, and I'm going to multiply this by this number right here, because if it says pull some fuel, then I'd multiply by this 0.96, and that's the number that I came up with doing this manually. Now you notice that's not exactly what number they put in here, so there's a little bit of a discrepancy. So again, you can calculate this manually, but this might get you pretty close. So what I normally recommend doing is when you're new to this and you're kind of going through this process the first time, rather than even in these areas where you know you're driving, just plugging in the numbers, I would split the difference between what you had before and what it's recommending. So it was recommending 12.6, I had 13.6, so 13.1 is about the middle region. So at 5.71 or 0.571 volts, I'd put in 13.1 kilograms per hour. So I'll go back to my tune, and I'm going to plug in 13.1 right there. And again, it's going to round things, and this is just what binary editor does. You can't have exact values all the time, so I'm going to get it as close as I can. We're going to go up to the next cell, 0.75. It's originally 18.7. Here it's 17.2. We split the difference. It'll be right around 18. So I'm going to put 18 in there. And I'm going to kind of work my way up until I get, you know, through about this far, you know, just kind of in this bottom range. I know this is even getting a little up past idle, but this is kind of the only range I'm concerned with right now. Okay, and you work your way through this. So you get the idea. And once you've got your new curve, you know, you'll want to save your calibration. When you hit save, it's always going to pull up a prompt, and you save it. You'll always want to save it as a new file, and I always recommend that you have a numbering system. You increase the number so you have different versions of your tune, and then a simple comment of what you changed. Make sure you keep this under about 60 characters or you're going to have issues loading your log later. And then essentially you'll load that tune, run your data log again, and go. Now, anytime you change anything related to your injectors or your mass air transfer because you're trying to dial in your fuel, there's another thing you need to do. Because remember, your computer just learned to add or reduce fuel, but now you fix that in your tune, at least theoretically, but it doesn't know that you fixed that in your tune, and it's still trying to compensate even though you've already added it to your tune to compensate. So now you're going to overcompensate and you're going to go too far the other direction until it relearns and comes back to hopefully about right. So what you need to do here is if you hit Control F, pull up your find, type in KAMRF, and you'll find this thing called KAMRF Reset Clear KAMRFs. And there's two of them here that you'll notice. This one says do not use, don't use it. You need to go to this one. So what you'll do is you load the old tune, start your data log, and start the car. And immediately after you start the car, while it's running, switch this from normal to clear KAMRF and hit the update button. Update is something you can do anytime the car's running. If you make like one change in your tune and you want to just load that one parameter change without having to stop the car and reload the whole tune, you could do this anytime you want. So you have real-time updates while the car's running, which is very cool on the QuarterHorse. So when you do that, update it, and what you'll see immediately if you're data logging and paying attention is those KAMRFs will immediately go back to 1.0. And if you don't change this back to normal, it will never learn. So you also need to make sure that it's once you clear it and you confirm that it went back to 1.0, set it back to normal and update it again. And then at that point, you just wait and let the car adjust. So again, let it run for a few minutes, make sure it's up to temp. You should start seeing the KAMRFs adjust one way or the other, and then you can go back and repeat this process. And after you do this 2 or 3 times, your idle should be pretty close. Now, you don't want to just assume though, and this is something that new tuners make a mistake of sometimes, is if your fuel's wrong, that doesn't just mean go to your mass air transfer and do what I said. That's one way to tune it. But if your injector slopes are fundamentally wrong based on what injectors you have, what your brake point is, and what you've set your fuel pressure to on the car, then you really need to make some changes to your injector slope or your fuel pressure, not the mass air transfer. So this is not actually the first place that you'd want to go to make a tune change. You really should pay attention to, are you fundamentally off? And the way that you decide on if you want to work on your slope or your mass air transfer is usually that if you have like a scenario, I'm going to go back to EEC Analyzer for a minute. If you find a scenario where just a couple cells here and there pop out at you and you notice it's kind of recommending a pretty substantial change, but in general it's not, that's probably an indication that your mass air transfer has a couple cells that need to adjust. But if you notice that like as a blanket statement that a whole bunch of these cells in the low area or the high area, whichever one you're kind of tuning, high slope is going to be the top, generally the top portion of your mass air. The low slope is going to be most of the lower cells. And if you notice that as a whole, they're all off and they're off by a similar percentage, like we could kind of universally say we were about 3% off all the way through here, then that's actually usually an indication that you need to adjust your injector slope or your fuel pressure. So let's say hypothetically, we decided, this entire low range, maybe even do a little bit of light cruising and driving around, and as a whole, you're off by 3%, and it seems to be running 3% rich. Then instead of messing with any of this mass air transfer, you would go mess with your injector slope, specifically your low injector slope. So let's go to that part of our tune. So down here in fuel and in injector, we'll go to here, and we have our low slope. So this is a kind of a rough measurement of what size injector you have. Your high slope is usually your indicator of approximately what, that rated slope is what you buy. If you buy a 24-pound injector, a 30-pound to 42, this up here is usually pretty close to that if you run it at the rated fuel pressure for that injector, which you may not be, but that's how they would usually match up. And this number is almost always going to be higher because the injector doesn't behave the same way when it's asked to do a very small amount of work. It usually has some extra fuel coming through. And so think about this concept. If I raise the injector low slope or high slope and double it, say I had a 100-pound injector or 200 pounds, something dramatically larger, to get the same amount of fuel through that larger injector, it needs to open much less. And if I reduce these and say, well, I had a 60-pound injector, but now I'm going to put in a stock 19-pound to get the same amount of fuel out of that, that 19-pound has to work a lot harder. So that pulse width is going to end up being a lot longer to get the same amount of fuel. So if I think that kind of in the low areas of my driving, I'm running 3% rich, I want to lean this out by 3%. And to make it squirt less fuel essentially, then I need to change this injector slope in a specific way. So I'm going to go in here and multiply this. And I'm going to increase this number by 3%. So I'm going to multiply it by 1.03, which essentially brings it up 3%. And by saying I have a 3% bigger injector, it'll believe that it has to work 3% less to get the same amount of fuel. So it reduces the amount of fuel you get, so it's leaning things out. So I would just make that one change, load that tune, reset my KAMRFs, and run another log rather than going into my mass air transfer. And that's kind of how I would decide to do one versus the other. So again, your low slope is really for idle tuning. That's a good place to start. Get your idle and some light cruising in. See if you have a consistent amount that you're off throughout that range. If it's inconsistent, just go ahead and work on your mass air transfer. But if it is off by a consistent amount, change your injector slope accordingly. And again, if your car's running rich, then you need to increase this injector slope. If it's running lean, you need to decrease this injector slope. And that's how you can make your adjustments there. The last thing I want to show you before this video is over, I'm going to jump back over to EEC Analyzer. I want to show you another tool you have here that helps you visualize truly the adaptive learning on this. So remember, I've got a big data log pulled in that had a variety of driving. I had idle, some cruising. I even think I hit wide open throttle at some point. So I've got a whole bunch of driving. It's a pretty long log. And I'm going to go to this mapping tab right here. And in this mapping tab, you notice that you have a series of cells based on load and RPM. And this is very similar to what your adaptive learning is doing. And on the top, and you can kind of pick from the things that you were logging, I'm going to put my KAMRF 1 up here, and I've got my KAMRF 2 down here. And what I'm going to do is tell it to go ahead and just calculate all this stuff. And what you're seeing here is essentially at a given area, load and RPM, what's the average fuel trim that the computer is making. And this is just a really good way that you can sort of visualize what the adaptive learning is doing. And so it's working its way through that long data log, and you kind of see it keep jumping around to different cells. But that's what it's doing right now. And when this is finished, you'll kind of get a sense of what's going on. So when I was idling, which was around 700 RPMs, and that's a very low load, you notice that it's making more adjustments. And then as my RPMs increase a little bit, not quite as far that it's having to adjust here. And then it looks like I'm running pretty considerably rich here. And then on some of these slightly higher loads, things look like they're actually pretty accurate. So this is the kind of setup that you have to go through to kind of understand this. And when we go to your adaptive learning in the tune, which is down here under fuel, adaptive learning, and I go to this update rate, this is another way that you can sort of visualize in the tune that same concept of how fast is it learning at a given RPM and a given load. And while these numbers may not be sort of the same scale as what you see here in EEC Analyzer, still helps you conceptualize what I'm talking about. So it's learning at each of these different driving conditions. Now, in order to make it adjust at all, you can't just be constantly on the throttle, off the throttle, and modulating it at all these different loads and RPMs. It has to stay in one of these cells for a certain amount of time. And so when you see these numbers here, you can change this in the tune, but the higher this number is, the longer you have to stay in a cell. So usually what I'll do is I'll start with free revving, and I'll just hold the car at 700 RPMs, and then I'm going to hold it again at 900 RPMs and maybe just sit there for 30 seconds, and then try to hold the throttle where I'm at 1100 and kind of hit all those different things for about 30 seconds each. And as I'm doing that, I'm watching the KAMRFs in my log and making sure they start to adjust accordingly. Granted, if you're just free revving and holding these things, you're probably only going to be in these low load areas, so that's fine. But to do the others, you'll actually have to be driving the car. So again, usually what I'll do, 5-speed car, I'll just kind of focus on my shift points, get into some area where I have no traffic, and just try to get things, where I can stay at kind of a very specific load, which then will probably be a little bit higher. but try to hold it at some different RPMs, probably up to about 2,500. And then I'll try to kind of stay at a heavier throttle, which, yeah, I'll probably be accelerating, but that way I can at least, again, hold these different cells. And that's kind of how you want to create a good log to measure your adaptive learning and to get these KAMRFs to adjust a lot of things for you at once. And that's what you'll go through. Go back, check your mass air transfer and your log using that tool, and rinse and repeat. And again, every time you do a cycle, remember, reset your KAMRFs, but then set that reset back to normal immediately and update it again. Run your log, and then whatever your new mass air transfer was, make sure you plug that in here before you start recalculating, or else you're making poor choices. You always need this to reflect whatever you were doing when you ran that log. Let it give you some new numbers, make your adjustments accordingly, run again. So that's kind of the basics of dialing in your fuel for idle, understanding how some of the adaptive learning works, and giving you a couple tools in EEC Analyzer to visualize your log and see what's happening. Appreciate you guys sticking through this. The next video I'm going to do, we're going to talk about how to use your wideband sensor to log wide open throttle, and a couple best practices there so you can get a good reading, and get that done. And once you get the idle, the light cruise, and your wide open throttle, that's pretty much all your fuel for your entire tune. And once you do that, then you can really start focusing on your timing and getting more aggressive there, and then ultimately getting the most power you can out of your car. So appreciate it, guys. Good luck. Godspeed.